Hi everyone. In this video we are going to look at something we call confidence intervals. There's two parts to that. One is where we use population proportions, meaning proportion just means a percentage, versus the population mean, and you'll know what the mean is, the average. So you're going to want to watch this video before you attempt homework number 16. And in the next video, I'll go over population means, and you'll want to watch that before you try homework number 17. Okay? So before we actually discuss what is a population proportion and a confidence interval, let's ask a question, okay? Let's say I ask the question, or let's say I'm interested in knowing what percentage of the community college population likes vanilla ice cream. All right? Well, we can't possibly go around to every community college in the country and ask people whether or not they like vanilla ice cream. But what we can do is we can ask a sample group of people. Now, it won't give us the exact percentage, but it will give us a sort of range of which the true percentage is in. And we want to do that to a level of what we call 95% confidence. And I'll get into that in just a minute. So the place you would start is with a sample group. So let's say, for example, I have a sample. I'm going to ask 900 people at Bunker Hill Community College whether or not they like vanilla ice cream. So I ask 900 people, so we know that's our N. N is always your total number of people. And let's say 400 people actually like vanilla ice cream. So we would say that our sample probability, our sample percentage, and that's what this hat over the P means, sample. We're going to use the small case letter P to represent percentage or proportion. Sometimes you see the word proportion. It's really interchangeable in this case. That's going to equal our 400 who like vanilla ice cream out of the 900 we asked. And if you actually plug that into your calculator, you're going to get 0.44. All right? So that's what the P with the hat means on it. So let's, before we move on any further, I want to go through a little bit of vocabulary, what we're going to be doing. Now, in a population proportion, we have a few things we need to think about. First is the P with the hat on it, the sample proportion. That's what we just went over. And that is going to be, your percentage of people who are positive in whatever your study may happen to be. So we understand P hat. Q hat, as you know, is the probability of a failure. It would, in our example, it would be that percentage of people that don't like ice cream. N is your sample size, which you're used to. Then we have something called an error. And before I talk about error, I'm going to go down here to critical value, another part of our problem in finding a population proportion and what we call a confidence interval. We need to look at what's called the critical value, which I discussed in my previous video on how to find critical values. So go back and watch that video if you're not sure how to do that. Okay, all of these leave us to a formula for finding what we call the error. Okay, and this is the formula here, and this is an important formula. You need to have it in order to be able to do your homework for number 16. What does it really mean? Error is that percentage that you must lie within. So, for example, if any of you have listened to sort of political polls, they say that Hillary Clinton is up by 2 percentage points in the polls with an error of 0.5%. That means the true range of where she is up in the polls could be anywhere from 1.5% to 2.5% because they're saying she's 2% up in the polls with a 0.5% or plus or minus. That means a 0.5%, 0.5%. Either way. So it's just what you think, a room for some error, okay, because we never know anything exactly. All right, so to find a confidence interval, which is a range, we say that the true percentage of the population, which is this P right here, it comes from the percentage of your sample minus the error, and the percentage of your sample plus the error. So it's between that you have to give or take that bit of error to find, and the true percentage will lie somewhere in there. And that's what a population proportion is. This little comment here we will come back to in a little bit. So let's leave this for a second and go back and try to answer our question. All right, so original question was, what percentage of community college population likes vanilla ice cream? And remember, we asked 400 people liked it out of 900. So we ended up with a p-hat of 0.44. Okay, so we're going to start right there. We're told that we also need to know q-hat, all right? We know that p plus q is always 1 that hasn't changed from what we learned previously, and so 1 minus the 0.44 is going to equal 0.56. So 56% of our population of our sample that we questioned do not like vanilla ice cream. Okay, we asked 900 people, and the next thing we need to do is find the critical value, the z alpha over 2. Okay, and I'm just going to do that very quickly because there's a whole video on that. But remember, critical values are based on this 95% confidence. That's where this comes from. We want a 95% confidence level, which means the critical values are here and here. Okay, and if this is 95% here in the center, then here the remaining bits are 5%, so 0.025% here, or sorry, 0.025 is a decimal, lies under here. Okay, so if you go to your z table and you look up that 0.0250, let's find that. Here it is. 0.250 is going to be right here. Oops. Let's get on that layer. Oops. All right, 0.250 is right here, okay? And that z-score was negative 1.96. Okay. So I'm going to go back here. And, let's turn on a little extra stuff on here. Okay, there we go. So that z-score was negative 1.96, and z over here is positive 1.96. Okay, so that's our critical, these are those critical values, the z alpha 2. And we're always going to just use the positive. This point, the negative comes into play when we're adding and subtracting the error. Okay, so 1.96. All right, so all that's left to find now is the error. All right, and the error comes from that formula. You can go back to the previous slide if you need to, but the error comes from the critical value, which is 1.96, times the square root of p-hat, which is 0.44, times q-hat, which is 0.56, and all of this falls under the square root sign, divided by n, which in this case is 900. Now you do need to be careful with this on your calculators. You can ask me in class too if you're having trouble. My suggestion is you just don't do too many steps at once. 1.96 divided by the square root of 0.44 times 0.56 is 0.2464 divided by that 900. Then do that step. You end up with 1.96 times the square root of 0.000273. You can take that square root and then multiply it by 1.96, and we'll end up with 0.0324. So you have roughly a 3% error. So whatever that hat was, that 44% of the population, of the sample that liked vanilla ice cream, the true population will lie within right around that 44% plus or minus 3%. All right, so how do we write all that? Let me put this here. Our confidence interval, if you remember from on the previous page, is your true percentage of your population lies somewhere between your sample population plus the error and your sample population minus the error. All right, and we just went through, here's our error right here. So the way we're going to write this in the end is our true percentage of people in community college that like ice cream are going to be, vanilla ice cream, is going to be that 44% or 0.44 plus the 0.0324, or in between the, should have written 0.44 minus the 0.0324. Okay, and then doing that in your calculator, your true percentage will lie between 0.4724 and above greater than 0.4076. Okay, and that's the way you're going to write the answer. Let's think about this in the end. Let's put this all together. Okay, in the end, we would say we are 95% confidence. Yeah, the way we would end this question of what percentage of community college population likes vanilla ice cream, we would say we're 95% confident that between 41% and 47% of community college students like vanilla ice cream. And that comes from, like I said, P is less than or equal to 0.4724 and less than or equal or greater than or equal to 0.4076, which again, if you round this to percentages, you get here it's between roughly 47% and 41%. Pretty cool, huh? And we can draw those conclusions. Sometimes another way you'll see this written on my stats lab is in these brackets with the lower limit of 0.4076 and the upper limit of 0.4724. All right, so go ahead and give the homework number 15 a try and watch the next video to do the population mean.